Hello, I'm Marie Hayes. I'm glad to see so many people here. We are pleased to have Dr. Thomas Herrington as our speaker tonight. He's the Associate Director of the Urban Coastal Institute at Monmouth University and also serves as the New Jersey Sea Grant Consortium Coastal Community Resilience Specialist. He has over 25 years of experience in coastal sustainability and hazard mitigation research, including, which is important for us, the analysis of storm surge and wave impacts on coastal communities. He's also a very accomplished hydrologist. He's co-authored over 100 publications in the field of coastal and ocean engineering. And I could go on and on with all his accomplishments. His resume is just amazing, including having an MS and a PhD in ocean engineering from Stevens Institute of Technology. And he's one of our very own, a graduate of Ocean City High School. So he knows Ocean City well and the problems we have here. So I'm pleased to present to you Dr. Thomas Herrington. Thank you.
Thank you. It's a pleasure to be here, a pleasure to come home, actually. Actually, last time I was around this area, this building wasn't here, I don't think. I think it was an aquatic center next door and a parking lot here, I think was what was here at the time. So things change, a lot of things change, and we'll talk a little bit about the environmental changes that are impacting us, and I think most of you are familiar with these impacts if you're living in the city. So I just wanted to start with a few definitions. I think you have experienced nuisance flooding, and you call flooding certain things here, I'm sure, probably things I can't repeat. But just what NOAA thinks about these types of flood events. And so when people use the term nuisance flooding, NOAA considers that, and that's the National Oceanic and Atmospheric Administration, flood events that occur, high tide, sunny day events that close roadways and interfere with your lives and make it very uncomfortable for you to do your daily activities. Chronic flooding is what we're going to get to today. That's defined as floods that occur 24 or more times a year. And that's considered chronic. So that's becoming to impact not just you personally, but the economy, the things going on in the community become negatively impact. So that's something where we start to say that's going to create cascading problems for the community. So we'll talk a little bit about that. And then king tide is one that I did not know about until probably the last 5 or 6 years. But you'll hear that in the news a lot. And what that is basically just what we would call the higher high spring tides, the tide we get for night in Venice, for instance, the one that floods the street ends because the tide's very high. So it's not something that's generating widespread flooding, but just a higher than normal tide. So we heard about my background, so I don't need to go through this. Most of my career has been spent studying coastal processes. I ran a research group at Stevens for 20 years where we looked at coastal engineering structures and beach changes. As part of that was a lot of outreach and education through the Sea Grant program. So I do wear 2 hats. The Sea Grant people always remind me to say, remember to tell them you're from Sea Grant. So, but they do have their logo on all of our slides. So why am I here? What are we doing here? And so this is a very interesting program that I got involved with through a friend of mine, a colleague at the American Geophysical Union, which is one of the largest scientific bodies in the world. They started this program called Thriving Earth Exchange, which pairs volunteer scientists with communities that need information and foundational knowledge about some scientific phenomenon that's affecting their community. And they had just partnered with a group called Flood Forum USA, which was a not-for-profit organization that's going out into communities that are impacted by flooding and getting some grassroots groups together. And Ocean City Flooding is one of those groups. And so through the AGU program, I got a call one day and they said, hey, there's this group in Ocean City, would you be interested in working with them? And I said, wow, I didn't even know there was anything going on in Ocean City. So we did meet up and partner, and it's worked out. And I'll show you a little bit about what we've been working on. The objective of the program is not for me to do studies for them and send things to City Hall and say you should be doing this and that. It's really to inform the people in the community, to empower you to make the decisions that would support longer-term sustainability, and that's really the goal. What are we doing through that program? So the actual project is assessing flooding and hydrodynamics for flood prevention and mitigation in Ocean City. And really it's to look at the flood issue from many different perspectives, not just today, but out into the future. What have we been doing as a community? What risks and vulnerabilities are coming? And what can we do to mitigate some of those? So there's two key flood issues that you're faced with here, and all coastal communities up and down the eastern seaboard have these problems. One is this shift in intensity and frequency of precipitation events. And so we see, this is actually, this figure over here on the left is basically the percentage of variability or increased percentage of precipitation we've experienced just from January of this year over the average. So we're running about 25% to 30% above average over this period. And that's something we're seeing more frequently. My friends at Rutgers University at the Climate Institute there, they gave me this other picture on the right. And what they're looking at is a shift in the frequency of events as the climate warms. And that's both heat, precipitation, and in some cases drought. So they've begun to track these things where they're looking at this shift from the average over towards the more extremes. And if we think of this as precipitation as well, we're seeing these higher intensity events more frequently. The second stressor here is sea level rise. And so I always tell my students, you can argue what's generating sea level rise, we could discuss it, but the data doesn't lie. This is from the tide gauge at the Steel Pier in Atlantic City. It's been in since 1912, and it has shown a consistent increase in sea level of about 4 millimeters per year, which translates to about a foot every century. And it's a very regular trend, and we have no reason to think it's going to stop anytime soon. So we do suspect that this is going to continue to be a problem for us. The result is more days like this, right? So this, I think, is a heavy rainfall, high tide flood event here in the city. So, and that's something that we don't really want to have to deal with all the time. So I was going to talk, look at these two issues separately, what's been going on and how we can address them, and then what we can look to in the future as these things are combining to create more a joint problem for us together. So heavy rainfall, higher tides are going to become more and more frequent. So there's my combined impacts. I jumped ahead of myself. And then we'll briefly get into some mitigation options. And I have lots of pretty pictures I might go through quickly to save some time. So stormwater management. So stormwater management in a community that has a lot of topography and elevation is something that can be achieved. You typically try to convey the stormwater off the streets into detention basins or into a discharge point as quickly as you can. But you need gravity to help you do that. You need to have some topographical relief. And we don't have that on barrier islands. We have very little topography, right? So it's a difficult challenge here to actually convey stormwater off the island when it rains heavy. Some of the issues we have is this low topography. We also have this very high water table underneath the barrier islands. I think all of your children can probably tell you, if you dig a hole here a foot deep or a foot and a half deep, you're going to find water, right? So the water table's high, so that doesn't allow us to percolate much water through the soil. That's the open space we have left. And we also, that also creates problems with how we layer underground infrastructure. So one of the first jobs I had as an entry-level engineer after I graduated many years ago was to come to Ocean City and try to figure out how to redesign the pitch of the stormwater outfall pipes. And so we went to an excavated corner down on St. James Place, and we said, wow, look, every possible utility line is about a couple inches below grade. So because there's no place to put them. And there's no place to put the pipes, and we can't pitch them anymore, and that's why we have these big long pipes that extend across the beach into the surf zone. because they're almost flat, right? So we're not getting much flow through them. So that's a challenge. So just moving stormwater off our streets, as you know, is a real issue here. What can we do to solve that? This is something the city's doing, actually, but this is from Miami Beach. This is Miami. If you want to go learn about all the problems that can result and what you may need to think about, go to Miami, because they really have problems. So here, the idea is you store the water as it comes off the streets, but you're going to have to pump it out because you need some way to move the water out of the retention basins out into the bay. And so that's an option. It's an expensive option. Many communities don't have the resources to do this, so it's not done much. But here, Ocean City is actually a leader in this. When we look at coastal communities up and down New Jersey, Ocean City is one of the few communities to take the initiative to invest in pumping and storage systems to convey stormwater off the barrier island. And that's great. I mean, that's if you have the resources to do that, that'll be a benefit to areas that flood frequently from rainfall. That's the big key, right? This actually came from, I don't know how many people may have seen this at public meetings, but this is a study Michael Baker International did for the city where it looked at the drainage areas and where we had problems in the city in terms of chronic rainfall, flooding, and they did a very nice job. They did a analysis of the watershed and the drainage basins. They did an analysis of the piping network, and they looked at all the pipes and the sizes of the pipes. And they created a model, a three-dimensional model that could look at, for every type of rainfall event, and then these are the rainfall events they studied, where the water was going and where it was collecting and where we saw that it was too much for the pipes to handle, right? So the report is very good. They come up with for different storm events, they can show where the water is flowing well in the green areas, where it's slowing down in the yellow areas, and the red areas are problem areas, right? And we can see they're at the usual points, the intersections, where we have the collection systems trying to keep up with the rainfall and the water's getting backed up. So they did use a study, and you're familiar with the couple of projects that are moved forward here in the city to put in pumping systems to help certain parts of the community. But it's not the whole community, and we think that over time, more and more of these systems may be required, right? So the second problem is the tidal flooding issue, right? So this is what we call nuisance flooding, sunny day flooding. This is actually not from Ocean City. This is Norfolk, Virginia. Norfolk, Virginia, or is that Annapolis? Yeah. Oh, sorry, Annapolis. Here you can see the waters come up over the bulkhead, and a colleague of mine, Professor Kriebel, who runs the ocean engineering program at Annapolis Naval Academy, has been doing a study for Annapolis and finding that there's going to be many more days like this. And the academy itself has a big problem with flooding. So this is all generated from just the astronomical tides, right? So this is just sea level rise and the tides riding across the elevated sea levels. So again, if we go back to our area, we're lucky enough to have this tidal record of 100 years plus from Atlantic City. So it gives us some ideas of what's been happening over time. And we can take this, there's the tide gauge if you ever want to go see it. I don't think you can get to it at the end of the pier. It's behind a metal gate, but it's there. And it was moved to Ventnor for a while when they did some maintenance work on the pier, and then they moved it back. But it's been there since 1912, and you could look at the data today if you wanted to. So what does it tell us? Well, we can look at a lot of different things. So what are these impacts we're seeing? This is the two or three storms we had at the beginning of March this year. And so the blue line here is the actual observed values from the tide gauge at Atlantic City from March 1st to March 12th. And the green line is the minor flood threshold set by NOAA, the National Weather Service. And then the red line is the moderate flood. And so the Weather Service goes out and determines where communities are impacted by different water elevations and determines if it should be considered minor or moderate. They do a lot of talking with the local OEMs to figure out what exactly those elevations should be. But when we look at this, we can see the blue line in these storms actually went across the minor threshold of flooding about, I think, 8 or 9 times, and it actually went across the moderate twice. So when we looked at this, we said, well, how bad was this storm? We heard a lot in the press that this flooding and the storm was so bad. Well, we took a look back and we said, well, what if we, one of the major storm events you may remember in our area was the March 62 nor'easter, right? So as a reference point, where would this storm rank in 1962? So we basically just take the water level and subtract 56 years of sea level rise. So we basically recreate the sea level in 1962 and then look at what the data would tell us. And what we find is that indeed, in 1962, this storm or series of storms would have maybe created 3 high tides of minor flooding. So that's the influence of sea level rise alone. In 56 years, we've gone from a non-event, an event that wouldn't have really created anything, to a pretty impactful event. And so same storm, different time, very different impacts. We can look at this into the future. We can add 52 years to our data, or 56 years. And what would this storm in March look like in 2074? Not many of us will be here to see that, but we can see now this red line crosses the major or the moderate flood threshold 8 or 9 times and actually gets above the major flood threshold once. Same storm, same data, just projected out. And this is just the sea level we've measured over the last 100 years, about a foot per century. So we can see that in the future, these are going to become much more significant impacts in our communities. So when we look at this, we want to understand, well, how impactful will this be? What should we be planning for, right? So how frequently will our roads be flooded in the future, right, versus today? And are we pretty confident that sea level will continue to rise at the same rate it's been rising for the last 100 years? Or should it accelerate just like the average global temperatures have been accelerating? So, and that's a scientific question that's still not resolved. But the climate modelers will give you some idea about what you may be in for, and you probably see that in the news reports all the time. So I just took a hypothetical kind of case study. I looked at a low-lying area. This is Roosevelt Boulevard into Ocean City on 34th Street. And if you look at this intersection of Bay Avenue and Roosevelt Boulevard, it's about 3 feet above sea level, right? That's the intersection elevation. And so that's a nice point to look at if we want to think about flooding. And so this is actually for every tidal gauge, there's actually relationships between land elevations and tidal elevations, right? So at the Atlantic City tide gauge, we can go and we can say, okay, here's the datum for the land, and here's the mean sea level relative to that. And it turns out the mean sea level is about almost half a foot below the datum the road is on. So in effect, Roosevelt Boulevard is about 3.5 feet above mean sea level right now. I mean, the tide range here is about 2 or 3 feet, so it's almost every high tide that this road could be flooded, right? So to give you an idea, this is that same March storm. This is the data from Atlantic City. I now have the flood thresholds kind of in these banded colors. And this is the elevation of Roosevelt Boulevard at the intersection. And we see that it should have, I didn't verify with anybody, but I would guess maybe flooded 10 to 12 times over those storms. So you guys lived here. I don't know if that's right or wrong, but if okay, so there's other lower points that we should be looking at, right? That's good. So what can we do with this? Well, what I did was I said, okay, let me look at the last 20 years of water data from the gauge. You can do that. You can download 20 years of data. And so I went there, I did that. And then I took out every high tide over those 20 years. And what that allows me to do is to see how many times the water was below or above mean sea level over those 20-year period. And what we can do in engineering and mathematics, not that I'll get into it, is we get this nice curve where mean sea level is 0, and the -2 would be water levels that are 2 feet below mean sea level, and +2 are water levels 2 feet above mean sea level. And so over those 20 years, as you would suspect, almost all the high tides are always at least 2 feet below mean sea level. That would make sense, right? We see that at mean sea level, almost all the high tides go above mean sea level. That's good. And then when we get out here around 2 feet, we see maybe 70% of all the high tides over those 20 years get 2 feet above mean sea level. And as we go out, it gets lower and lower. So when we get out to about 4 feet above mean sea level, that's a very rare event, right? That's a storm. So maybe an easier, oh, this is just a bigger picture in case you wanted to see it. I probably should have used this one. Same data, same picture. But here I have plotted the tidal range over that. So this is the spring or the mean lower low water tide. This is the mean higher high water or spring tide. So this is the tidal range. And there's the 20 years of data that shows that most of the tides should be in here. And then we have this 20% of higher tides, which are storms. Right, they're the storms in the record. Now here I've also plotted the elevation of Roosevelt Boulevard, 3.4 feet above mean sea level. And we see that right now, oops, I'm going to go back, that is very impacted here. Not impacted very much, but there is an impact that there are a certain number of high tides that get above the elevation of Roosevelt Boulevard. Probably an easier way to think about this is how many number of high tides per year should I expect to be above the elevation of Roosevelt Boulevard. So I've taken the same data and I've said, okay, there's 2 high tides a day over 365 days. There's about 730 high tides a year. So how many of those high tides are over a certain elevation? And so now I can say, okay, here's Roosevelt Boulevard's elevation, and there's about 24 tides per year that will be above that elevation based on the 20 years of data I have from Atlantic City. So, well, that doesn't seem so bad, 24 tides. Can drive around that, right? But what does the future look like? So we can add sea level rise to this data, right? So now if we go back, and NOAA's done some studies and they have sea level rise projections, and they don't trust themselves, so they have this range of sea level rise based on different assumptions about climate change, right? So if we look at this black line is the historic trend. This is the 1 foot per century trend that will continue into the future. And then here's a low estimate of sea level rise by 2100. Here's a medium, a high, and a highest. And so they have different rates, anywhere from about 1 foot, which is the historic, to 6 feet, depending on which model of the climate you believe. So
A foot over 100 years?
Yes, or, well, by 2100, so we're less than 100 now. So what I've done is so this is our data from the 20 years for today that we looked at before, and now this is at 2100 with 1 foot of sea level rise, 2100 with, I think the low range, 1 and 1.6, I think, the medium, and you can see if we're out here at the high ranges that the number of high tide events that are getting out to about 8 to 9 feet above mean sea level become quite significant, right? And we can look at this, we can put Roosevelt Boulevard on here, and we can begin to see that today we have about 24 high tide events, but with 1 foot of sea level rise, which is this gray curve, we're now looking at maybe 150 in 2100. If we have the low range of NOAA's estimate, we're up around 375. So that's every high tide a day is over the elevation. So this is when we start to conceptualize what climate change impacts will be. This is one that's pretty probable because sea level certainly will rise 1 foot in the next century, right? So we're definitely going to see significant impacts from that. This may be an easier way to look at it. Here I've just taken, this is the number of flood events that flood Roosevelt Boulevard today. And this is, if we use the existing linear trend, by 2100 we should have over 100, maybe 125 flood events. If we look at the highest range is one of my favorites, because you see it kind of tails off here. That's because at some point, about 2080, if the real change, this significant change should occur, every high tidal flood, right? So we'll become Dutch. We'll have to build walls. So this is an area of concern. Yes?
Excuse me.
Yep.
At what date did we change the measuring of the sea level from manual to satellite?
That's a great question. So it is still measured manually, right? So we do still, every one of the tidal stations that NOAA operates is actually an acoustic sensor that measures sound travel to the surface of the water. But the satellite measurements, I think, come around 1995, 2000, and that's this box in here. But I haven't seen many published papers that come up with a great comparison between the historic tide gauge locations and the satellites, because the tide gauges are on land and the land is sinking. Yes. Right. So the Pacific Northwest is rising. So it's very hard for the satellite guys to resolve this problem. And the one way they want to resolve it is to create a whole new datum called a geoid, which will use the, magnetic field? I'm looking at the only surveyor I know in the audience. It will use the Earth's magnetic anomalies, basically, to determine the exact position of sea level. And that's just not there yet.
Yes,
Yeah.
sir. Go back just a little bit. You said the West Coast is rising and we're sinking.
Yeah.
Go back a little bit. Define sinking.
Okay.
What
Sub-
causing this?
right, okay, so
That's a good place.
subsidence. Subsidence is the true tectonic term. So, right, so what happened is with the last ice age, about 12 million years ago, 12,000 years ago? 1,000 years ago, there was a giant block of ice on top of the eastern seaboard about as far south as New York City. And that ice pushed the crust of the Earth down. And as the glaciers have melted and retreated, the land that they had originally pushed down are rebounding or they're rising up. And what's happened is, as that rebound has moved north into Canada, we originally rebounded, but now we're subsiding because as the crust on the northern Canadian landmass is rising, we're tilting down. And so, right. So that is about 2 millimeters per year. So of the 4 millimeters per year I showed in the graph, 2 of it is us sinking, and 2 of it is the sea level rising due to expansion. Yeah, but we're not bad. I mean, there's some places in the Gulf of Mexico that are seeing 12 to 14 millimeters per year of sea level rise, mainly due to hydrocarbon extraction. So they take the hydrocarbons out and the crust collapses. So the Pacific Northwest, to just finish that thought, is closer to the rebound, and that's why it's rising. You're welcome. Okay, I'll hurry up here. So we're not too sure. We're learning. There's been some recent publications that are looking at variations in sea level rise, and what we're finding is it's not consistent everywhere. And it's not just due to this tectonic response. It actually has to do with a lot of other elements. These are decadal bars from, let's see, 50 to 60 down to 2010 to 2015. These longer bars are the sea level rise rates we're seeing over the last 15 years pretty much. And we're seeing that in places like Norfolk, Annapolis, Atlantic City, much higher rates than we have seen in the past. And so what we're beginning to learn is that there's other physics involved, that part of this is actually due to the current speed in the Gulf Stream waning, right? So the Gulf Stream currents are actually getting less and less intense. And the response is that the sea level rises here, right? So we're seeing some other dynamic effects that are affecting sea levels here. And so now we're starting to think that, well, this 1 foot per century is probably not going to pan out. We're probably going to have a little bit more than that for sure. And so there are some issues we're looking at. The next thing is, well, what happens when we have heavy rain and the tidal flooding? This is Venice. This is a heavy rainfall. And the canals are up over their banks. And so we're just beginning to look at what we call joint analysis of rainfall and tides. And what we're finding is that we're going to have to start, and this is just, don't worry about this picture at all. But basically we're trying to look at what is the probability that we'll get 20 or 200 millimeters of rainfall at the same time as we have an 8 foot or 8 meter tide. And this was for China, so don't take this anywhere. But this was a 10% probability over however many years they studied. But they don't have much data. And so we're just beginning to learn these things, and that's kind of where we want to focus our efforts. So I think I'll stop here. We could talk about mitigation later. Maybe I'll come back down. But these are just some of the concluding thoughts is that, and I think the main one is here, is that, I love this little quote, this isn't a slow gradual change anymore. We're seeing the impacts now, and these impacts are going to get worse as we move forward. And so we need, as a community, need to think about how we can begin to mitigate this future of ours, which will soon make us look like Venice if we don't think about how to better resolve or mitigate some of these issues. So I was told to keep it at 30. You never tell a professor, or never, you always should tell them, because if you let them go and just let them talk, we'd be here for 3 hours. So.
Can I just ask one question before you fully conclude?
Yeah.
So you're saying that there are things that we can do to mitigate our flooding right now in Ocean City. We just have to find the
Right, and
tools.
let me just let's filter through some slides. Flood walls are probably not something you want to do, but where's my here? So, our friends at the Army Corps of Engineers have been thinking about this ever since Sandy. They have a huge project, a $3 million project that will be complete around April of 2019. And they're starting to think about the entire Back Bay area and how we can start to treat the edges. A lot of it has to do with kind of natural features, levees, living shorelines, dikes, that can be used to keep these kind of high tide events at bay. And we can design them to any elevation we want. Ocean City's a little bit ahead of the curve in this instance, because if you do that, you definitely need a pump system to take your rainwater out once, because if you think of elevating the edge, you create a bowl like New Orleans, you're going to need pumping to get rainwater out. So Ocean City's a little bit ahead of the curve there. At least the pumping systems are coming in. The edge treatments are where we need to look. And somebody had asked about, or maybe Suzanne, you mentioned that the council had said, well, who's going to pay for all this? And so I will say there's two things to maybe you want to talk about. One is the Army Corps is doing a significant study. This will move forward after April 2019. Probably take them another 6 years, to be honest with you. But they'll come up with some designs, and they're going to go to Congress and ask for money to build some of these with the state. And so there will be projects that come out of that, and it could be that Ocean City can take advantage of that, just like our Beachville project, right? There's one other opportunity out there, and this is one that came out a week ago or 2 weeks ago. The New Jersey DEP has a resilience grant program that they're kicked off 2 weeks ago, which will provide up to 5 groups of municipalities. You have to partner with 3 municipalities, $200,000 to plan for resilience. And they don't want you to do it on your own. After they select the winners of that application process, they will ask for proposals from the consulting, engineering, and architecture community to work with you on developing your vision and your plans. So they really want the communities to think about what's best, what fits best for them, what they think resilience will look like in their community, and then they're going to give you the resources to really do it and really create a good plan that then they will, the DEP with you, will go out and try and get funding for it.
Dr. Herrington,
Yeah.
don't worry about squeezing our meeting. I'll worry about that. This is really interesting. Could you go into some of the resiliency plans that exist right now, or what kind of options what will these grants pay for, basically?
Right, well, so they're planning grants. So they won't build a project. I've been told that explicitly by the DEP. We're not going to build anything. The Army Corps may build something, but so they really want communities to think innovatively, to look at ways to both, I guess, restore or adapt the natural environment around them to help them become more resilient. So that's one big effort that they have. But really, it's like a design competition. It's very similar. I don't know if you were able to follow it, but after Sandy, the Housing and Urban Development Agency put out hundreds of millions of dollars for a design competition called Rebuild by Design, where all the big thinkers, all the architects and landscape people got together and said, well, what would we do differently now that Sandy's impacted us? And they came up with interesting ideas like a huge offshore reef around Staten Island to mitigate storm waves and surge. And they're building it. They're building this giant offshore reef. It's both habitat as well as storm damage prevention. And so they're looking for ideas like that. It doesn't have to be on that scale, but certainly what we're hearing, the academic community's hearing from the DEP is we would really like to see communities start to be active participants in the planning. We want their thoughts. We want them to take ownership so that you shepherd it through the process.
And we're trying to find people to partner with. Ocean City Flooding is working on that grant.
Yeah. So it has to be 3 contiguous communities. So you have to find your neighbors. So that would be Summers Point, Longport, Strathmere, Beasley's Point, right? So you'd have to find them. Yes.
It's my understanding that Ocean City, Maryland doesn't have a flooding problem. And it seems to be because they have a uniform bulkhead system across their entire bay.
It may be. I don't know. I'm trying to think.
Unlike Ocean City, now you mentioned that we're going to have these pump stations. They're going to put the water back into the bay.
Right.
And then it's going to come
Right.
back over because we don't have a uniform bulkhead.
Right.
We have an ordinance that requires the bulkheads to be certain standards, but the city doesn't monitor that. So the city went through and they put these bulkheads at the street ends, but they're private individuals.
Right down. Yeah.
No, they haven't. One of my friends that works here, he paid all this money to fix his bulkhead, and when we had our last storm, I said, how'd you make it out? He said, I got flooded. I said,
Oh.
It came through my neighbors and
Yeah.
my property.
Yeah. I think that's.
And that's one of the main problems that we have here in Ocean City. We're kidding ourselves with these pump stations. We pump the water
Right.
into the bay, comes right back in.
Right.
We have to do something about the bulkheads. That's the only way we're going to stop flooding from the bay.
Yeah. So just 2 thoughts. I guess I don't know too much about the Ocean City, Maryland case, but it sounds like maybe they were able to do a uniform bulkhead.
They did. I believe Atlantic City has a grant to do something similar.
Right. So there's all kinds of issues with private-public property issues, right? I know the council here has raised the minimum elevation for replacing your bulkheads, but you're right. That's a piecemeal solution that may take decades to get done, and so it's certainly something that we.
They don't enforce their own ordinance.
Yeah. Well, that's it's a local issue that's got to be worked through. Yes.
If I can get away from politics, which
Yeah.
I think is at your work, it's very interesting practice. Away from the politics, okay? What's the climate, and how do you know when it changes? Okay, when I took 50 years ago, when I took geology, there were C1, C2, D1. I mean, is there a point at which now you're in a new climate, or is it just one of those things?
So climate's not weather, right? Weather varies year to year. So climate has to persist over decadal scales, right? And so have we entered a new climate? So there's many people that will tell you that in their mind we have gone out of the Holocene, which was the most recent geologic age, into the Anthropocene. because it's now at the point where we are actively modifying our climate. So that gives you an idea of the scale, right? It's something on the order of hundreds of years, if not more. So it's hard to pick. So that becomes really part of the challenge of messaging what is weather and what's climate. And I'm not the one to answer that question. I'll tell you that. So.
Now, a political.
Okay.
You talked about how high the water table is.
Right.
Okay, there's two things, since you've been in high school, how much bigger are the houses compared to the land? So nothing can go in at all anyway. The other thing is, we pay, I calculated this, in the summer, 4.5 cents a gallon for water. Okay? Because we're paying for the water that goes into the sewer, but what goes on, by legislation, you must have irrigation on your lawn. Wouldn't neighborhood shallow wells provide the irrigation without having to pay 4 cents a gallon, and not having to take clean fresh water?
Well, you do have a freshwater aquifer underneath you. I don't know how deep it is. About 10 feet. So
Not the aquifer, just the runoff.
yeah. So
Stuff
because that lens sits on top of the salt water, right? So I don't know. I've never thought about it, but I don't know how much you could draw out before you completely draw it down.
Well, why water it?
Well, that's a different issue. I'm
Make the
saying,
lawn natural.
no, if for
That's-
forest reasons, other reasons, you want green lawns, great. But why take
No,
this?
we have to convince people that this is a barrier island, not a country club.
Yeah, well, you know, people have to go for the environment, it'll cost them money.
Right. But I'll tell you, many of my colleagues at Sea Grant advocate for natural landscapes, both for habitat as well as much more sustainable, right? You're not going to replace your bayberry bush every couple of years. So, but you know, it's I don't know, it's private property rights, but the ordinances are a problem, I would think.
But they wanted to do it on curved streets.
Oh, in the, so there. Well, you could use that for rainwater retention, though, but that has to be designed as a bioswale. There's guys at Rutgers doing that in certain communities.
Ocean City uses on average through the year 2.5 million gallons of water a day. That includes summer irrigation, public irrigation, and private home use. And my question, well, already there's saline intrusion down county and out on the Delaware Bay, and then we're talking about subsidence of the land because we're drawing so heavily out of the two aquifers, the 800-foot sands, which connect to the Kirkwood Cohansey. So we are contributing here with high volume water to gradual subsidence of our island or the mainland of New Jersey, or both.
Oh, is that a question or statement? I think
Yeah, because we're a barrier island, we're already on water.
right. Well,
We're contributing to the
I would think that the salt water would gladly take the space of the freshwater, although the chlorides are a little bigger, so they may not get into all the spaces. But you know, you're recharging the aquifer with salt water, which is a problem, right? So I think there used to be an artesian well right down here on 11th Street, right? That's no longer there. So
We still have 9 artesian wells in use.
yeah. Now I
Connect 800-foot sands out of,
yeah.
or unless you know differently, this is what New Jersey American told me that we
They don't connect. They do, so they do not all connect uniformly. It has to do with where the bedrock lies and the consolidated clays and silts. Maybe you know, the geologists, but it is a huge aquifer. The East Coast aquifer is one of the largest in the world, and it's, you know, there's two. There's one from about New England down to North Carolina, and then one from North Carolina into Florida. Florida's like extracting all the water possible out of their aquifer right now, so they have real challenges there. But from what I've seen and read from the U.S. Geological Survey, intrusion's an issue, but they don't see it as a major issue at this point. But could be in the future.
It's just an observation that I have, and I'm not a scientist, or an engineer. But everything so far that I've heard sounds like something that's very good for the short term. And when I say short term, I could be talking 25, 30 years. We're building on every square inch that we have. As soon as it becomes empty, they build something on it. So where then does the water go? And won't we eventually just simply end up with a smaller island, even in the best case scenario? Sea level
Right.
rising, sinking, land,
So yeah,
building, nowhere for water to go, nowhere for the tides to go. And
Oh,
then come in.
that's a very good observation. And the planning horizon, when I have meetings with different planners, I think that planning horizon is 80, 100 years. I don't think there's any certainty after that, so they're not really thinking that far ahead. But you're right. I mean, if it's done incorrectly, you will have a walled-off city in a bathtub, you know, and that's something that
Yeah.
the regulatory world doesn't want to see, right? So when you talk to people in the DEP, they're like, we have to make sure we're ahead of this so that we're not doing that, right? But your question is good. Well, how long do we really have? And
Especially if it accelerates.
right, and I think there's these are just personal observations, two things. I had a really good colleague at North Carolina Sea Grant for years who would say, this sea level rise stuff, yeah, that's nice, and we can do all kinds of interesting things with it, but it doesn't matter because the next thing that's really going to impact you is that next storm. So it doesn't matter how high the sea level is if there's another Sandy on your doorstep this year, right? So his view had always been that it's going to be these episodic storms, these impactful large storms that will change the coast and change the way we are. Sandy, in a sense, has done that. It's changed our reaction to how we view storms and respond to them and prepare for them, really. But it hasn't changed the way we developed. and so people in my financial community will tell you, at one point or another, things are going to not be that easy to finance. And it's going to be, at the municipal level, it's going to be the bond rating agencies that are going to say, wait a minute, you guys aren't doing enough to reduce your risks. We're going to not give you these really good rates. Or it's going to be the insurance or finance industry for personal loans, right? And we're seeing that play out in Miami right now. Miami's probably going to be the first place we see the financial community step back and say the risk is too high. So, and then what happens? That's going to be a question.
They have major issues with
Yeah.
that water
Yeah.
on their land. I did see that.
So, one more?
In your discussion so far,
Mhm.
it seems to me you're treating water in terms of moving it, not removing it. What
Right.
efforts are-
Right.
We know that water can exist, well, in 4 different stages. We're worried about the frozen water in the Antarctic, and therefore coming to the liquid level. What efforts have been made to turn it to the gaseous level and burn it off?
Burn off the. Oh.
They're both
So,
burnable.
right. Yeah.
So remove it. Don't worry about moving it. Remove it.
Remove it completely. I haven't thought about that, to be honest with you. I have just read some interesting concepts about refreezing water under the Arctic, which is there are some ideas of creating large-scale freezing and pumping systems that would stabilize the glaciers. To where that goes, it's usually the engineers that come up with these ideas, and immediately the science community says, absolutely not. But there's also, in Europe, in the European Union, there's a big effort to put in carbon dioxide scrubbers to reduce carbon in the atmosphere. And that can be drawn out not easily, not cost effectively, but we can actually begin to reduce carbon in the atmosphere by cleaning it through filters. So, but these things take a worldwide kind of crisis and initiative that we don't see, right? And so the same with this idea, right? It could possibly work, but how do you get it at the scale where it makes a change? And we don't see that in the world community. We're not great leaders, to be honest with you, because we backed out of the only climate agreement we had. And what's a shame about the Paris Climate Agreement is that was really hedging our bets. We, basically saying if we can keep the increase in global temperature to another 2 degrees, we may survive this. May, right? And so, we backed out of that. And so we're not leading the world in any direction. So that's probably. Yeah, well, that's another issue. Well, that is a challenge. And that, I will say, and we were able, and maybe this was just at such a different scale, but if you remember the ozone hole, when it was understood that it was the hydrofluorocarbons that were causing that damage, well, that worldwide industry changed, quickly, and was able to mitigate to some extent that hole. So we have been able to do things like that in the past, but this is on a scale that is really challenging. Is there a question back here?
On the mitigation side.
Yep.
The Army Corps is doing a good job keeping our beaches in pretty good shape. Ocean City floods from the base.
Right.
In fact, that whole all those things on their chart.
Right.
You couldn't drive.
Right.
The ocean side is fine. So beach nourishment sort of works. It's not the greatest process in the world. What are some other options on the base?
So I'll show you one they're really looking at, and that's all these little red bars. And where are they located? Across the inlets. So one of the things the Army Corps is really thinking about is putting in surge barriers at every inlet and closing the bay off. That is probably $1 trillion project. But that's a concept you have to remember the Army Corps listens to what Congress tells them, and Congress says, you got to stop flooding and damages. And so they go off and they say, okay, we're going to look at what we're going to call flood risk reduction. And whatever does that the best at the most cost-effective price point, we're going to build it. And the locals can kind of have some influence on that. But this is one they seriously, and when I talk to my colleagues in the Philadelphia district office, and they're doing this work, and they'll say, well, we think this is the most practical and environmentally just solution. That's the new buzzword, so learn that one. Environmentally just, right? And that's because it protects everybody. So, this whole area, not just us here in the island, it protects Lower Township, Middle Township. And so that's something that's an option, right? But is it, to get back to cost effective or feasible, we don't know. And in the state's level of budget thinking, it's like, my God, I don't want to even think about it. They're already in crisis mode over the cost of these beach fills because they never expected every one to be built. But after Sandy, the federal government came in at 100% federal dollars and built every beach. So that's a big cost for the state. I think
Wrong, correct me if I'm wrong. These pump stations are helpful. They're good because you take Merriam Park, for instance, and Simpson Avenue. There are no bulkheads.
Right.
I mean, it's not whether the city is enforcing or not. There are no bulkheads there. Until bulkheads get put in there, but should they get put in there, you need the pump station. Otherwise, you're in a hole, like you said.
Right. So if you were able to.
Yeah, but the pump stations are being proactive. I mean, I don't like paying for them, but I think.
Right, and I think you're going to see other communities follow what you're doing here. They just have to.
If I can just inject a little humor, there used to be a commercial. It said, "Collector with a friend," which means shower with a friend. You can save water. People can shower.
Yes.
Yes, sir. My name is John McMorgan, and I come from the south end.
Okay.
And my home faces the interstate waterway. And I'm here for my whole street. report back to the
Okay.
on Saturday. First of all, you gave 3 indications about south where we live, we're sinking.
Right.
2, the ocean is rising. And 3, what's the third one you said?
The rainfall increase or the
Rainfall is increasing.
right.
Now, you had indicated that no real movement's gonna really happen fast until the next Sandy comes along, God forbid. Let's just say Ocean City misses the bullet for the next 3 to 4 years on any major hurricane. Yeah, we'll get some storms. How far do you see the bay rising in the next 5 years if no major storms really hit us hard?
So
Between those
right.
3 categories, between rain increasing, oh, there's another one, 4th one, the Gulf Stream.
The Gulf Stream,
slowing down.
yes.
The Gulf Stream's slowing down, we're sinking, the ocean's rising, and more rainstorms in the next 5 years.
Chicken Little. Well, I don't want you to leave and go back and say the sky's falling. No, that's not what you're saying. No. But right, but you're right. One of the problems is that this is a persistently increasing risk that doesn't dramatically change overnight, right? So it may not matter in 5 years, but it will matter in 15 years, right? And so can you take steps now to prevent some of the problems you have or you will have in 15 years? You could. And you could think about, if you wanted to, incrementally increasing your defenses over time if you had the ability, right? Because that would keep up with sea level rise. It's not going very fast. But the problem is when we don't think about them and we neglect them, and then one day, somebody notices, wow, I can't get out of my driveway every other weekend. And so that's when I think you start to realize that this isn't random. It's actually somewhat of a chronic problem that's affecting life, right?
Now, we're gonna have, Dr. Harrington's presentation available for the Facebook page before Saturday, so you'll be able to share it with people.
He's sure to explain those graphs.
How does the condition of the inlets affect the back bay flooding? In other words, if the inlets are filling in with sand and becoming shallow,
Right.
is that causing water to back up in the back bay, or is it keeping water from getting into the back bay? Like, if the inlet fills in, is that making things better or worse?
So inlets, it probably will make it worse if it's really shoaled, especially if you have a high runoff event that can't flush. But inlets will, when they become hydraulically unstable, they will breach somewhere else and recreate the hydraulic connectivity they need. And so, for instance, for years before we started mining Great Egg Inlet, the channel would move south across towards Ocean City and become very unstable, and then it would breach through the middle. And actually that actually brought sand to the north end this is 100 years ago, but that's how, a matter of fact, the gardens section got so wide. It was one of these welding of the shoals due to the inlet reconfiguring itself. So if left to nature, they will actually remain hydraulically stable. So it's hard to keep them from doing that. And even when we go out and mine and move sand, it could only take one storm to create havoc on that hydraulic equilibrium. So I think there are times when it could create flood issues, but I think they're probably short-lived because of the way the inlets are so dynamic.
In the beach fill cycle, the inlets end up getting screwed up, they get shallow.
Right.
Shifts. And I'm wondering if in that period of time, if the back bay flooding is worse because the inlet is
I think,
so messed up.
right, I would think right before they do the dredging work is probably when it's the worst. When it's nice and wide and deep, it's moving a lot of water through.
So it does have an effect.
Yeah, I would, yes. I don't know what magnitude it would be. We did actually, I can give you a reference point. When Sandy created the breach in Maniloking, we had a modeling group at Stevens that simulated that breach and looked at the exchange of water, and the impact wasn't that tremendous, maybe an inch and a half locally of extra water behind that inlet. But it did change, and then they closed it off very quickly, so we didn't really get to see much more impact than that. But we did see an inch or so. It actually went up in the back, because there was no tidal exchange there ever, and now all of a sudden you had the tide going into the upper Barnegat Bay. Yeah, yeah.
One of the other presenters that we had indicated that one of the reasons that we have the back bay flooding is because the islands that we have back there are sinking. Is there anything that we can do to mitigate that problem?
So so that's it is. There are people thinking about this, and mainly not for the reason you're thinking about. They're thinking of the fact that with sea level rise, the marshes are not able to keep up with the how quickly the water's rising over time. And so there's a lot of conservation groups, including the Nature Conservancy in New Jersey, Barnegat Bay Partnership, that are trying to build up those marshes through a process they call thin layer spreading. The marsh,
Let us do that.
they won't know.
That would have solved our problem to get rid of the
Dredge material. Well, so what, and this is all kind of relatively new. The regulatory side hasn't caught up to this process yet. So there's still a lot of issues with contaminants in the materials. If putting that on the marsh is something they don't want to do. They have done, Avalon, I think, had two marshes that were built up with thin layer spreading from the intercoastal waterway dredging. So they are trying it. We're trying to study the impacts. We want to understand if we're doing it right. Nobody's ever really done some work in the Chesapeake, but we don't have much to go on. So, but I think you'll see that more frequently. I think as they go to do their maintenance dredging, they're not just going to dump it somewhere. They're going to put it on the marshes.
That would be good.
Yeah. So was there one over here first, or?
The intercoastal waterway dredging, resource material would be subject to greater water flow and less accumulation of contaminants, so that deposition of intercoastal waterway dredge resource material
Be cleaner.
be cleaner as opposed to, say, residential lagoon dredging with high pesticide, herbicide runoff residue into the lagoon resource material.
Yeah, I would guess you would have many more contaminants in the, and depending on, in the old days, we used to have the creosoted bulkheading and things like that really were not very good for the environment. So, yeah, that has to go to the soil testing, which has to be done before you place it. So that process has to play out. So, I don't know, another question or?
Any other questions?
I just had
Sure.
one.
Yeah.
Because I don't know if it's measurable or not, I don't know if it's insignificant, it may be insignificant. But for years you watch them do beach replenishment, and it's not just here,
Oh,
they're
yeah.
doing up and down the coast. Is that having any kind of a measurable negative impact on currents? With, you know what I mean, you're pulling, they do it over and over again, and it's,
Right.
I would find it shocking if it wasn't having some kind of
Currents up.
impact.
I'm trying to think if there were any step somewhere along the way. I'm sure the Corps put a current meter out somewhere, but it hasn't. That isn't something they do much. I will say what we find is that the beach environment is so used to tremendous dynamic change that it seems to be able to recover from these, even when we manipulate it, go back to its equilibrium state quite quickly. We do see some issues with rip currents in some places, that's for sure. But probably the bigger impact is where we're taking the material from. Here it's Great Egg Inlet for the most part, or Corson's Inlet. So those inlets recover quickly, but there's some locations off Long Beach Island, for instance, where it's in deeper water, and we're seeing some negative impacts where they take that material from. So, you're welcome.
Thank you, Dr. Herrington, for a very interesting and informative night. We also want to thank you for all the help you've given pro bono to our Ocean City Flooding Group. Dr. Herrington's taking us this Wednesday to Brigantine for a tour of the living shoreline to help us understand what we can do here in Ocean City. We want to give you a taste of Ocean City. Some Shriver saltwater taffy and Johnson's popcorn. That's good. And one of our members, Donna Moore, has a cedar tree, flood resistant. And thank you. And I also want to thank Suzanne Hornick, our Ocean City Flooding Committee Chairwoman, for helping us to bring Dr. Herrington tonight as our speaker. Bill and Sheila Hartraff have brought FIT pamphlets, newsletters, and membership papers. You can help yourself up there. Suzanne has some flood signs for your yard if anybody wants any. This concludes our speaker presentation, and we want to thank you all for coming. We meet every Wednesday, first Wednesday of the month at 7 here, so please come and join us, and we'll be having a short board meeting right now. Thank you.